Our next question is from GATE 2018, Instrumentation and Process Control, for 2 marks. You can see here, match the following column A with item in column B. Here phi denotes the phase shift, K1 K2 is the process gain, tau is the time constant, and R is the amplitude ratio. So let's start with the solution. You can see here, for pure dead time system, it is a transfer function. For pure dead time system, it is 1 e to the power minus tau ds. For this, there is a multiplication of 1. So here a amplitude ratio is 1. Remember this, amplitude ratio is 1 for pure dead time system. Right, phase shift is given for this is equal to phi is equal to tau d into phi is equal to minus tau d into 180 by pi. Right, so in degree centigrade. So you can say for pure capacitive system, we will use for pure capacitive system. For pure capacitive system, GS is given as K by S, and you know that we will put S is equal to I omega, right? And if I multiply and divide by I, then I got I upon I square. I square is minus 1, so it will be minus I upon K upon omega, and it is the form of A plus IB. For A plus IB, right? For A plus IB, phi is equal to, actually it is a phi is equal to tan inverse B upon A, and since there is no A, so it will be 0. So B upon A, K upon omega by 0, it will be tan inverse infinity, and it is in negative, so it will be minus tan inverse K by omega upon 0. So it will be minus tan inverse infinity, it will be minus 90 degree, right? So you can see here, for pure dead time system, amplitude ratio is 1, and pure capacitive system, phi is equal to minus 90 degree. We will check for further. First order process with unity gain, amplitude ratio is given as AR is equal to 1 upon tau square omega square plus 1. Here is 1 since unity gain. So amplitude ratio always amplitude ratio first order transformation always in 0 to 1. So it will be in 0 to 1. Third, it will be 0 to 1. So we almost, I have already matched all these. So, but we will check for inverse response also. You can see here, for inverse response, it is a given transfer function. GS is equal to K1 by S minus K2 by tau S plus 1. You can see here, we will do one thing, K1 into tau S plus 1, right? I am just solving this. GS is equal to K1 tau 1 minus K2S plus K1, right, upon this. For inverse transfer function, it is important to calculate, to check the zeros. So if I put this equal to 0, then it will be equal to S is equal to minus K1 upon K1 tau 1 minus K2. So I can write it as K1 upon K2 minus K1 tau 1, right? Since I minus 1 multiply here, so it will be K1 upon K2 minus K1 tau 1 as equal to this. And it is given in the question that K2 is greater than tau K1. If it is this, it is K2 is greater than tau K1. K2 is greater than K1 tau 1 or K1 tau. So it will be positive. S is equal to positive. So there is a positive 0. Whenever there is a positive 0, there is a inverse response present, right? Inverse response present. So you can see here from the question, for pure dead time, P should be fourth. P should be fourth, right? For pure capacitive system, Q should be phi. Q should be first. Q should be first. R should be second, and S should be third. So option D is correct. Option D is correct. So thank you. Please make sure to like, share and subscribe my channel. Thank you.